Hello, my dear class 9 students, welcome back. So today we'll continue with the part 2 of chapter 12, sound. Okay, so in the last class we have discussed about how sound is produced. We have discussed about the different type of waves, transverse wave and longitudinal wave. So transverse was and vibrating of if the particle, okay, if the individual particle of a medium, they vibrates perpendicular to the direction of the propagation of air, and then this was the longitudinal wave, okay, when they are parallel, okay, when they oscillate in a parallel direction. So now today we are going to discuss about the characteristic of waves. Characteristic of sound waves, okay. So as you all know, sound travel in the form of a wave, right? So we'll see in this way, okay. Today we'll see in this way. So here, let's say this is the density or pressure. Here, this is the distance. Clear? So students, see, sound travels in this form, okay. What did I say? Sound produced through vibration, right? Now vibration means to and fro. So this is how they travel. Clear? To and fro. Now students, up till here is considered to be, it's considered to be one oscillation, okay? One oscillation. See, up till here it is considered to be another oscillation. Clear? So in the last class we have discussed about the rarefaction and compression, right? Compression and rarefaction. And I said that compression happens at high temperature, high pressure and density, right? And rarefaction happens at low pressure and low density. And compression is when the particles come together, when they are crowded, and rarefaction is when the particles spread out. So students, this is the compression, this is the rarefaction, this is the compression, this is the rarefaction. Okay, and then this is the compression. So this peak is also known as crest, okay. This peak is also known as crest. And this valley here, the depression point, here, this is known as trough. T-R-O-U-G-H, trough. Okay, so this, the peak is also known as crest. So this is crest, this is trough. Now students, first let's discuss about the wavelength, okay, wavelength. We'll discuss about the wavelength, so I'll write here, okay, 1, wavelength. Wavelength. Now wavelength is the distance between two consecutive compression, clear? Distance between like two consecutive compression. So this one will be the distance, right? This is compression, and this is compression. So the distance between two consecutive compression is known as wavelength, okay? Or the distance between two consecutive rarefaction, okay? See, this is rarefaction and this is rarefaction, right? Rarefaction. So these are the region of low pressure and density, okay? Low pressure and density. This is also low pressure and density. So this is rarefaction. Rarefaction. So the consecutive distance between two rarefaction or the distance between two consecutive compression is known as wavelength. Okay, so note it down, clear? And then it is represented, okay, now you have to know this one. It is represented by, wavelength is represented by this sign, okay? See, this sign. Now what is this sign called? This sign is known as lambda, L-A-M-D-A. Okay, so wavelength is represented by lambda. And this is the sign. And if you are asked what is wavelength, then it is this one, okay? See. This is the wavelength. So it is, once again I'm repeating, if I'm repeating, that's very important, okay? So it is the distance between two consecutive compression or two consecutive rarefaction. Clear? So that is about a wavelength. Now next characteristic would be frequency. Okay, so this one will be the second, frequency. Okay, so students, frequency is number of oscillation per unit time. Clear? Number of oscillation per unit time. So that means, see, I told you this is one oscillation, right? This is one oscillation. So in one oscillation we have one compression, we have one rarefaction. Then that means this is one oscillation, and then this is another oscillation. So frequency in a simple word means number of oscillation per unit time. Okay, how many oscillations is possible? Okay, per unit time. So that is about frequency, and frequency it is represented by, I'll write here. Okay, frequency it is represented by this sign. Okay, see, it is not V. Okay, it is not V, students, it is nu. Okay, NU, nu. This sign is known as nu. So frequency is represented by this one. And the SI unit of frequency, SI unit of frequency is Hertz, which is represented by Hz. Okay, Hz, Hertz. So Hertz. Okay. So SI unit of frequency is Hertz, which you can show in this way, Hz. This is the symbol. Okay. Now that is about the frequency. Okay, so students, see, I'll show you for this example. Now the sound. Okay, the sound, the normal sound that human being can hear would be like between 20 Hertz to 20,000 Hertz. Clear? So here, this Hertz means that is the SI unit of frequency, right? So that means we'll use this one, okay, Hertz. So this is how we apply this in a unit, in a sound chapter. Clear? Now students, amplitude. Okay, the third characteristic would be about amplitude. Clear? Now amplitude, it is represented by A. Okay, see, A, amplitude. Now the SI unit would be meter. Clear? The SI unit would be meter. Now amplitude, in a simple word, okay, in a simple word will be the height of the wave. Okay, see, this one, clear? Height of the wave. So students, the loudness of a sound, okay, the loudness of a sound, it depends on the frequency, how high the frequency is, okay? No, on the amplitude, I'm sorry. This is amplitude, right? I told you this amplitude is the height of the wave. Clear? So the loudness of a sound, it depends on this amplitude, okay? How high our amplitude is. So, loudness of a sound depends on the amplitude. Clear? So if we have, you know, like this, student, if we have like this sound wave, then the amplitude would be just this much, right? So we'll say that this one, it has a lower sound, right? And this one, it has a loud sound, right? Comparing to this one. If we compare this one and this, the second one, then which one will be louder? this one will be louder because the amplitude here, you see the distance, you can make it out right from the diagram. Clear? So that is all about the amplitude. Now see, frequency, I said that it is the number of oscillations per unit time, right? So the pitch is a characteristic of a sound, right, students? Pitch is a characteristic of a sound, and this depends on the frequency, okay? Frequency. Now, frequency means always, see, compression and rarefaction. Frequency means number of oscillation per unit time, right? That means whenever I'm saying oscillation, means to and fro, right? See, to and fro, to and fro, to and fro. So, the pitch is a characteristic of the sound, and it depends on the frequency of the wave, okay? So keep this in mind. Now, next point will be time period, okay? Time period. Time period, okay? So students, time period would be, this is the formula for time period, okay? This is the formula for, so that means it is inversely proportional to the frequency, right? Now, time period means I'm drawing another sound wave, okay? So the SI unit would be seconds. Clear? So now time period in a simple word would be how long is it taken, how long, okay, it is taking to complete this oscillation, one oscillation, okay. So one oscillation means this one, right? So what is the time taking, right? What is the time taken? So time taken to complete this one oscillation, okay. So that is all about the time period. This is the formula. It is inversely proportional with the frequency of the sound wave, and SI unit would be seconds, okay? SI unit would be seconds. Clear? So students, I'm sure you're familiar now with the wavelength, okay? And then the second, we have discussed about the frequency. Third, we have discussed about the amplitude. Fourth, that is the time period, okay? Time period to complete the oscillation. And we have this pitch, which is to do with the frequency, and we have the loudness of a sound, okay? Loudness. I'm sure you have shouted, right? Whenever you shout, you know, the loudness of a sound, that is to do with the amplitude, okay? So students, that was the characteristic of the sound waves, okay? Now, I'll give you a formula as well as a relation so that we could do the numerical problem. Now, in physics, you will always, there will be a numerical question, okay? There will be a numerical question, and those numerical are very simple if you know the formula. Clear? Okay. So I'm sure now you are clear with the oscillation, right? How this oscillation, vibration, and then compression and rarefaction is coming. Okay. So keep this in mind. This is the compression and this is the rarefaction. Okay. So in one oscillation, that means to and fro. Going, coming, going forward, coming backward, going forward, coming backward. That is how vibration takes place. That is how sound is produced. Okay, that is how sound is propagated. So keep those important points and you can note it in your notebook. Clear? So now we'll study a relationship between the speed, frequency, and wavelength. Okay. Okay, so students, relationship between speed, clear? So speed is represented by V, okay? Speed, frequency. Now do you remember? I've just given how it is represented, right? Frequency, it is represented by nu. And wavelength is represented by this lambda. Okay, so now we'll see the relationship between them. Clear? So we have speed is equal to frequency into wavelength. Clear? So this is the formula. So now we'll apply their sign. So this is speed, this is the frequency, and this is the wavelength. So this is one formula. Clear? Now, with the help of this formula, we can find the speed, we can find the frequency, and we can find the wavelength. Clear? So let's do one numerical problem. Clear? Okay, so students, let's solve this numerical. Okay, now here's the question. Calculate the wavelength. Now, calculate the wavelength. So that means we have to find the wavelength, right, of a sound wave whose frequency is 200 hertz. So we'll write given. So what we'll do is, in a numerical, first you list down the ingredients, okay, whatever it's given. Clear? So now given frequency, this is the frequency, right? We have 200 hertz. Clear? Now speed. Speed is given 440 meter per second. Clear? Now what we have to find? We have to find the wavelength. So this is what we have to find. Now students, do you remember the formula that we have discussed just now? Just now we have discussed that speed is equal to frequency into lambda. This is what we have discussed just now. So we'll substitute the value here and we'll find the lambda. Okay. So now we have speed, that is, speed is 440, right? Now the frequency is 200, right? And this is the lambda. So this is what we have to find. Clear? So in this case, what we will do, since we are trying to find this one, so we will write this one here, and this one we'll divide it with 440, right, by 200. So this one is like a cross multiplication, okay? Cross multiplication. So what you do is, we can cancel this one, okay? So now 20 into 20, 44 will divide with 20, so you will get 2, okay? And we'll get 2. Now wavelength means, so yeah, 2.2 is our answer, but the unit is important. Without the unit, you will not get the full mark. So student, wavelength, okay? Now wavelength means it is about the distance between these two or these two, right? Between two crests or two troughs. So distance means it is always in meter. Clear? So this is our answer. So by applying this simple formula, by applying this relation, we can solve any question. Clear? So student, that is all about this relation between the speed, frequency, wavelength, and also the characteristic of a sound wave. In the next class, we'll discuss the other topic which are left from this chapter. Thank you.